The human hand is a remarkable thing. When building the humanoid robot, Elon says it's by far the biggest problem to solve. But why is this the case? Well, we're going to break it all down for you today. I have Gustav Andersson with me. Gustav is a hand surgeon and associate professor of anatomy in northern Sweden. If you're a regular on this watching our podcast, you know him very well. Welcome, Gustav.
Thanks for having me. We've all been dying to get some news from the TeslaBot community, or for the TeslaBot community, and from Elon.
That's
so happy to have his speech at the All In podcast the other day.
Yeah, I mean, it was really brilliant, and I think we've got a lot. We've heard a lot of what he said about Optimus and the hand and the challenges of it, right? But there were some touch points that we're going to talk about today. So let's begin by listening to this soundbite from Elon.
Why the hand is so important to get right, and why, the actuator design is so unique, and why it's so difficult, why nobody makes it, and why you have to start there almost to build the rest of the robot properly?
Well, it turns out the human hands are they've evolved to be this incredibly sophisticated machine. Like your hand is actually a remarkable thing. Look closely at your hands. And think of all the things you can do with your hands, which is a lot.
I can think of many things. Yeah, I was just thinking about something.
Your hand's a very versatile instrument.
Yeah, you can give a high five.
Very versatile. You can swing a baseball bat. You can thread needles. You put thread in a needle. You can play the piano with violin. You could disassemble or assemble a car. The hands are incredibly versatile instruments. Most of the muscles of the hand are actually in the forearm. So your hand is kind of like it's like a puppet. Like it's mostly a puppet. The muscles are coming from the forearm, and they're pulling the tendons, which are also human tendon design or human tendon evolution is incredibly good. So you've got this web of tendons. You've got I think the human hand has something like, depending on how you count it, 27 or 28 degrees of freedom per in the hand. It's amazing. So in order to create a robot that can be a generalized humanoid, you must solve the hands problem.
Yeah. We had Ari.
It's got hands, needs hands.
Yeah. And so is it like when you were first building Tesla, where the supply chain doesn't exist and now you have to go out and find folks to work with and build all this vertical integration, get support? Is it literally like it's just nowhere to be found and you're going to have to build all of this stuff up?
Yes, we could not actually buy the actuators for any amount of money. They simply didn't exist, even though there are, 10, 20,000 electric motors out there of various sizes and shapes. We've had to design every electric motor, gearbox, and the controlling electronics from scratch, basically from physics first principles.
Well, the good news is you've got a lot of experience with factories over the last couple of decades. So how challenging is this versus Cybertruck, Model Y,
Model X,
Gigafactory, the Fabergé egg known as the Model X? Yeah.
Right. It's harder than any of those things.
Okay.
Yeah.
Much harder? Significantly, yeah.
Starship?
Yes. Well,
harder than Starship?
No, not hard. Starship's harder. Starship's harder.
So somewhere between a Model X and a Starship.
Yeah.
What's harder, the hardware or the software?
Right now, we're struggling with the final design of the hardware. Like I said, it's really primarily the hand. Not to just dismiss the rest of the robot. The rest of it's also important, but the hands inclusive of the forearm are a majority of the engineering difficulty of the entire robot.
Yeah, it's tough to emulate evolution. It is.
Yeah, and I mean, somewhere between the Model X and the Starship, kind of defines my surgical field. It's almost rocket surgery. No, it's nice to hear him kind of
Acknowledge
acknowledge the problem,
Yes.
or
the challenge.
The challenge, definitely. And he earlier stated that the Tesla bot will have human or dexterous hands similar to humans, which gives me hope. We're grasping at straws at the moment because we haven't really seen anything aside from
Literally. I love that.
yeah. And no, but still he comes back, and maybe that's why we wanted to have this talk about where the muscles are. And I could share that. Yeah, so it is true, the hand and the forearm.
It is true.
It is true that there are a lot of muscles in the forearm. He is right in a way that the hand is controlled in a similar way as a puppeteer would control the puppet with strings. There are a lot of muscles in the forearm controlling the finger and the hand, and most of the power is developed by those muscles. But if you actually count them, the muscles in the forearm and the hand are more or less the same numbers. Looking at them closer, they kind of look like puppet strings going down into the fingers and the hand to control the wrist movement and the finger movement. But you can't really get away from the fact that there are around 20 muscles also within the hand, controlling the finer motions and the fine control of the fingers and thumb, the things that really make the human hand unique, I'd say, in the animal kingdom. And there are some muscles in the forearm that aren't really used in the hand function. These, for instance, are just to rotate the forearm. So yeah, Elon, you're right that it's a lot of the hand function is controlled by the forearm muscles, but there are a lot of them in the hand, and I still think that they are important to not forget. And I hope that they have kind of appreciated that they exist and that they are there for a reason, to not kind of go down a path of engineering where they kind of miss out on these finer control from the muscles in the hand.
Absolutely. And here on the channel with you and Scott Walter, we've always been saying that the Tesla Optimus team needs to speak to a hand surgeon, needs to speak to an expert to really understand and truly get a grasp of the challenge. And Elon, or anybody from the Tesla team, if you're listening, Dr. Gustav Andersson here is the best you can get.
Yeah, and we heard from the meetup in a few months back that they had visited a hand surgeon down in Silicon Valley or wherever it was. So at least they have that idea, and I appreciate that. And I'm quite sure that there are engineering solutions to kind of emulate the muscles that we do have in the hand, even if you place them up in the forearm. I mean, the clone bot has tried to emulate the human anatomy as far as possible, but I still think that those cables or their tubings go up into the forearm and of course into the torso of their bot. So you don't have to put it in the hand, but you need to realize that there are muscles there that need to be emulated. And I mean, when it comes to the grip and the hand function, we sometimes divide it into centralized grip and peripheral grip. We talked about this a little bit before. And when it comes to like grasping objects or even key grips, and the tripod grip, a lot of them are actually from the hand. And as soon as you put a heavy object in your hand, it kind of becomes a part of your body. It's now I have full control of the tip of this. I don't need to do a lot of fine motions. My hand is basically still or fixed. The wrist is fixed, and then I just use the arm. Whereas if I'm going into more finer control, maybe not even threading a needle, because you can kind of fix your hands and just put the needle or the thread into the needle. But if you're going for smaller, fine work with using pens might not be necessary, but using a pair of scissors or balancing them and your pair of pliers when you're trying to get somewhere, or then you really need the control. And unscrewing a cork of a bottle, for instance, that's your tripod grip, which is mainly perhaps can be controlled by your forearm muscles. But when it comes to the twisting of the cap, you kind of need your intrinsic muscles. We've seen some examples of bots emulating this, but it will be interesting to see how they approach the whole intrinsic muscle problem that we talk about. And in our hands, they are also very important for the proprioception, or the providing the central nervous system with information about how the fingers are positioned and so on. And these things will probably be solved by other means when it comes to the bots. But it might be that having some of the actuators actually in the hand might make this also a lot easier.
So from everything that you've seen with the Tesla hand, and let me just pull up the one with the air guitar, is Tesla on the right path?
Yeah.
In your opinion?
So, I mean, we got excited when we saw this. It was kind of hidden in the bushes at the AI event. And at first glance, it looks really quite impressive, but it's still just using big motions of the forearm muscles, which is of course important. But playing the guitar or the violin, you really need the fine control of your fingers, being able to extend the intraphalangeal joints while keeping the MP joint stable, for instance, and just bending and stretching your fingers is not going to solve it all. So I like that approach. It's a way of making the hand less bulky to move them out of the hand, and you could add more joints, which they have with the MP joint flexion of the fifth digit to easier reach opposition, even if they put it up here instead of down there. So I'm really curious on what version 3 will be. He kind of agreed, or Scott said that the present bot videos that we've seen are mostly likely V2.5 or 2.5, and Elon kind of verified that version 3 has not yet been seen. And I'm really looking forward to the hand. We've seen them already show the bot being able to pick up eggs and doing certain things in their training facility and catching the ball. It's definitely capable of doing these things. So yeah,
which by itself is pretty remarkable for it to be able to do that. And I think this is the Gen-2, right?
Yeah, so that is probably Gen-2 or 2.5. I mean, the hand on the left is probably Gen-2. There was a previous version as well of the hand that kind of was just a 3D render or the really early prototypes. But yeah, this is version 2. And this is supposed to be the tendon-based design. At least they said that, but looking at this forearm, it's a much slimmer than the ones we've seen otherwise, where they kind of assemble the bots, and you could see the actuators in the forearm that looked a lot more bulky than this hand does. So maybe it's like somewhere in between. They're using different parts for different things. So.
Yeah. But I kind of find it interesting that there is a certain evolutionary aspect to the development of Optimus's hand, a lot like our own hands through evolution. But you made an important point earlier, which I would like you to maybe dwell on a bit more and explain to our audience. Why are our hands, human hands, different from those of, let's say, apes or monkeys in the animal kingdom?
Yeah, so the evolution, I guess no one really knows exactly why it went the way it did. But I mean, as we left the trees and went down to look for things, started using instruments, or not instruments, but the tools, having a hand designed for that task was, of course, a benefit, apparently. So that kind of was kept around, whereas having 2 long digits as the chimpanzee and a quite short thumb was not as ideal. So the chimp thumb is a lot shorter than in comparison to the metacarpals and the fingers of the human hand. So it has kind of developed in that way. And there are also theories that using tools and using the hand to make a mark on our surroundings that also have affected our brains. So it's not just that the brain has kind of learned how to use the hand, but the hand has, by being used, made the brain develop in a certain way. And also, like when you're learning things, if you're doing it by hand, writing by hand, or painting, or touching an object, it's a lot easier for a lot of people to kind of remember and to learn new tasks and things. So the brain and hand
Yes,
are really
absolutely.
close.
And I've always wondered about that. Why is it that
Mhm.
you learn something, or you retain memory or understanding of something better when you're writing it down?
Yeah, and similar smells are really strongly correlated. But yeah, the hands are connected there. And then I guess also, so the reason why we do have the muscles in the forearm and not all of them in the hand is because being able to produce the force that we need in gripping and whatever we're going to do, if all of that would be in the hand would be gigantic to be able to kind of create the torque and the force that we need. So that's why most of them are here for a reason.
Yeah, kind of like Popeye's arm.
Yeah, exactly.
Which is what this air guitar version of the hand really looks like, right?
Yeah.
It's really bulky.
Mm. And I mean, as Elon mentioned, they had to kind of design all of the actuators themselves, the gearboxes, all of the things. So this is probably very early prototypes, and I'm kind of expecting it to shrink over time and being more designed for the bot, and not just taking what's on the shelf at the moment to try to get the motions. And I mean, from evolutionary point of view, the muscles came before the hand. I mean, you had contractile proteins evolving over time, from going from, I don't know, the basic cell to the worm, and then working their way up towards to mammals, of course. So the contractile element, or the small muscles, were already there before humans evolved, long before. Whereas now we're trying to go the other way. We know how we want the hand to look and what functions it's going to have, but we don't really have a good muscle
How
equivalent.
difficult is it to reverse engineer something that is perfected by evolution?
Yeah, I mean, in certain aspects, probably not very. I mean, if you put a bunch of medical doctors or scientists or whatever in a room and ask them, how would you improve the human body, what would you remove and what would you add, there would probably be a lot of suggestions of removing redundant parts, designing the eye in a different way. We're really impressed by how good the eye is, but the way it's been designed kind of gives way to pathology and disease. You would not put inside the eye, the vessels are in front of the light receptors, so there's a big risk of you becoming blind, because you should have it on the other side instead if you designed it. And there are, of course, things that are no longer used by us. One of them is the tendon here in the middle. It's like a vestige tendon. Most of us have it. I don't know if you can see it really, but it really just, it's even removed in this model. What it does, it's this tendon. It makes like a plate of like a flat tendon in the palm, and we don't really use it as a muscle anymore. Whereas earlier primates, they have it as a quite strong wrist flexor. But for us, it's not really important. We can remove that and still have a very well-functioning wrist. So for us as hand surgeons, this tendon is basically the perfect spare part. We just take it and put it where we need it if something's broken. So that's good. And there are a lot of those. I mean, yeah, I'm focusing on the hands. So reverse engineering, yeah, maybe you don't want to, but we have things that are really hard to engineer. I mean, like synovial fluid and joints that kind of repair themselves. And Elon also said that the tendons have evolved in a good, that we have nice tendons. And I agree. I mean, they're pretty good at recovering after injury. And sure, everyone has had like a swollen tendon or inflammation around the tendons, but they heal, and we don't really have bots that can heal themselves yet. So we'll just have to repair them the traditional way.
Yeah. Well, I mean, I would imagine that there perhaps would be at least 2 or 3 different approaches to developing the bot version of the human musculoskeletal system. right? And we've seen actuators, and then we've also seen the clone bot hand and their version and their methodology of approaching it.
Yeah, and I guess at the moment it's the traditional actuator design or variants of it is the most well-functioning, but I kind of hope that clone sticks around and develops their more like hydraulic type of muscles, and there are probably other things out there up and coming with contractile materials that could be used, but it's all very research lab bench level at the moment. So if you're in a rush to get the humanoid bot out there, you should probably go with what's pretty well developed and established already, even if you have to kind of design the actuator in-house. At least you know how to build them and not try to reinvent something.
Yeah, but that's also been the case with with every single one of Elon's companies, right? They're so vertically integrated, and they want to be that they end up inventing stuff at a crazy rate, right? Whether it's the mega blocks and the transformers that they've just built in with the bus system for the mega blocks, or even if it is just actuators, as Elon was detailing at the All-in Summit.
Yeah, and that's why I really like that they're really going for the humanoid hand. I mean, they could easily have gone for a much simpler design. And as he was asked, like, why do you really want the human hand? And we've talked about this before, but if you really wanted to do everything a human can, it needs to have the human form. And
my question to you then is that, do you think that they're going for the generalized hand right now?
Yeah, I mean, it sounds like they're going for the final design. It will probably improve over time, but it's similar to the gull wing doors or the falcon doors of the Model X. I mean, it's not just having them move up and down, but they have these sensors that they had to build to not have it knock into people, and it had to be able to penetrate the door, which there wasn't any sensors that could do that at the moment. So they had to build them indoors. And if they kind of decided that we want the perfect human hand, then they will have to solve these things that are not available at the moment. But then that's why I also get a little bit nervous when it says, oh, it's just these muscles, it's not these ones. And as I said, sure, you could probably emulate the muscles moving the thumb and splaying of the fingers. They've already showed that they're doing that with the air guitar, but not as much. And it's like the kind of, we'll see if they keep this hinge of the fifth metacarpal, which I would like for them to have down here, similar to this like artist's hand, which has the opportunity to make to move the fifth metacarpal a little bit at least. So this type of design is a lot better than many of the robotic hands out there, because it emulates the human form a lot better. But it's not, of course, actuated or has any motors, but I can shape this almost perfectly into the shape that my hands can do. And a lot of the robotic companies, they just have a flat palm, which kind of worries me, because sure, you will be able to grip things, but not as well as we can by forming the arch of the palm and moving the little finger towards the thumb. And in this air guitar hand, you never see the thumb actually touching the little finger. It just goes to maybe the middle finger or something. So there the CloneBot has come a lot further, I think, at least what we've seen in their demos. It's still very early development, of course, but hey, it actually goes to the ring finger there.
Yeah, it is.
So when they've decided on that, I really hope that they kind of figure out what it all means, and not just we want the perfect human hand, but we kind of skip a lot of things that at least me as a hand surgeon think is important. So yeah, we'll see. I'm really looking forward to their Gen-3.
Yeah, I mean, so that's a perfect segue to my follow-up question, which is, what is if you're going for a generalized robotic hand, what's the MVP? What's the minimum viable product?
Yeah, I think they already have
functionality.
Yeah. I mean, then you could, if to use the words I had before, it's like just go for the centralized grip patterns, which a lot of these already have. And some say that, oh, this is a very dexterous hand now. It can do a tripod grip. It could grip with the hand, and it can do the key grip. It's a lot of robotic developers kind of consider that a dexterous hand. It's of course functional, and you can do a lot of things. You could grip your power drill, you could grip the key to open the door, and you could, if you also get the tripod grip stable, you could pick things up, and if you also get the twisting motion, you can open a lot of, or screws or whatever. But that is still,
or bottle caps.
Yeah, or bottle caps. But that is, so that would be
But that's a combination of both, right? So isn't that more a combination of the twisting motion, depending on what? If you're using a screwdriver, that's fine motor movement. But if you're opening a jammed bottle cap, you're also using
the bigger ones
and the forearms along with the grip power.
And I mean, I'd agree. And so a lot of them are starting to do the splaying of the fingers and not just fixed MP joints that are hinged like. And I think you need that you can't skip. And then if you design it by having the actuators up here, I think it would be just a bit more complicated than having it close by. But fine, you could do that. But I really think you need to be able to do this with your fingers and not just open and close the grip. There are, if you really want the next level, not the minimal viable product, but the most valuable player MVP, then you need this intrinsic function, and also the thumb. Of course, a lot of them are emulating the opposition of the thumb. That is, I think almost everyone is doing that at the moment, except was it 1X or someone who has fused their thumb in a locked position, at least at the moment.
Yeah, I think it's 1X.
Yeah, so that, I mean, it will be able to do a lot, but it won't be a dexterous hand without the. I mean,
because you also have the 3-fingered hand, like from Boston Dynamics and a few others, which can do a good number of tasks.
Yeah, and that will be a good product in the warehouse and in certain delivery of packages and so on.
Even
but but it won't be able to, or maybe it will. But I mean, there are a lot of plumbing and stuff that will be tricky for it unless it can reach in with small fingers and unscrew certain things. So,
So tell me something for the audience. What should they know? Why do bot companies show the hands in the way that they do? Why do they choose to show certain particular actions or movements or the ability to carry out certain tasks? What are they signaling?
Yeah, so there's quite a lot where they cut off. You never see them actually picking things up, but it's placed in the hand, and then they can do fine motor skills like threading the needle, for instance. I haven't seen a single bot pick up a needle yet. There was a clip the other day, which we might discuss further on, where they added the nails to be able to pick up a coin, and I like that idea because the softness of our fingers and then the support of the nail, the fingernail, will help us pick up thin objects like a coin or a nail. The nail with a nail. So there are certain things like that is also shows that they realize that the nails are there for a reason. It's not just something that we have. They are important for the grip of our fingers and the support of the soft pads. If we remove the nails, the soft skin would just wobble around, and it's quite tricky to use your fingers. So the nails are not just for aesthetic purposes and clawing people or scratching them. It's also for how we use our hands. And also the softness. I think we see in a lot of, they put gloves on some of these bots, but there are also those who have a bit like squishy pads, which not only will perhaps be part of the sensing sensation, but also improve the grip. If you have
what about sensors? What about touch? Because the touch is it's such a vital part of the way we use our hands, right?
Yeah, I mean, a hand without sensation, it's hard to say that it's worthless, but it's really the worst type of hand. You could lose 2 fingers and get a stiff wrist and stiff joints. As long as you can feel, it's a much better hand than if you have a fully functioning hand, but you have no sensation. Then that hand will be really you won't use it. You unless you don't have a choice and it's the only thing you have, then you will use it. But you would have to look at everything you're doing, and just imagine picking something up from your pocket and not being able to feel it, or I have to get the sock out of the bag. If you can't feel that it's the sock, you would just have to empty the bag to be able to find it. So sensation is extremely important. It will be really interesting to see where that goes also.
So we have this phenomenal ability to adapt to loss of touch, or if we lose a finger or we lose a limb even. How does your experience and understanding and learning from these circumstances in humans, how does that translate into what you need for a bot hand?
Yeah, I mean, the bots will probably be even more adaptable once the AI gets really high level. But when it comes to patients, for instance, losing sensation is the hardest to get over. Of course, pain and suffering is hard. If you have constant chronic pain, that will of course be debilitating. But if you don't have any pain, losing a few fingers, people will adapt and they will learn how to make life work. Living or work, but if you lose sensation in your hand, or if you take a prosthetic, for instance, if you lose your entire hand, or if you're born without the hand and you provide this individual with a myoelectric prosthetic, it can be very advanced and you can move the fingers similar to these robotic hands that we're seeing. There is a very high degree of patients removing the prosthetic because they don't feel what they're doing. They rather have their stumps to kind of feel what they're gripping, and they might use it for expression or aesthetic purposes. But there are some who actually use it quite a lot. But we have a really hard time getting children born with lack of fingers or lack of a hand to use a prosthetic. They might use it for aesthetic purposes, but when they get home, they remove it and they use their hands. So we're good at adapting, but we need the sensation, and we haven't really heard much about that yet, aside from that they have touch sensors. But what the bot is perhaps better than us potentially is by vision, knowing what it should feel like or how heavy it is. I mean, we rely on it to control our muscles and our grip. It might be that the bots will be able to, based on simulation training and just downloading information, they know how heavy is a Coke bottle, how much force do I have to exert on it, whereas a human being might not be as good at intuitively knowing and controlling the muscles. We control our grip and our strength by feedback loops from the sensory input from the skin and from the muscles, spindles, and all the proprioceptors that we have.
That's fascinating. How much of that feedback loop do you think can be replicated and applied to developing the robot hand? And I would imagine that you would need sensors in that.
Yeah, you would need some sensors, and there are of course the ones that are just in the skin of the bot, but then also the actuators themselves responding to the weight or to gripping things. So I think we would have to emulate both the surface, what it feels like touching it, but also the weight, getting information about things, exerting force on your hand or the robotic wrist or the fingers. So you would need both in the same way that we do, but I'm expecting them to rely on vision a lot more, at least in the beginning, to kind of see what they're doing, and that's how they are trained teleoperatively as well. The teleoperator, usually they get some force feedback, I guess, but they usually have to really look at what they're picking up and adapt their grip. So yeah, I hope that they go quicker to image or video based training and not teleoperating. Because you will probably train them wrong if you want them to be as similar to us as possible.
Yeah, it's a lot more complicated and messy than it appears. Yeah. Okay, so I've been dying to ask you this question for a while now, right? So when our peripheral nervous system is a sort of a peripheral brain in so many ways, right? And when we look at the sense of touch, it's not just pressure, it's also temperature. It's a whole, so the ability, so do you think there is the possibility of replicating that and some sort of peripheral computing in bots the way we do it as humans? Because that takes it to a whole different level.
Yeah, I don't know. I would expect it to be able to. I mean, there are these really impressive like Kuga arms or robotic arms where you can kind of draw with your finger on the bot and it will interpret what you're writing without having any sensors. It's just the actuators or the servos that are responding to your touch. So there are these kind of techniques, and then you have the real surface sensors that respond to pressure and temperature. Of course, shouldn't be a problem. Pain, perhaps we don't want to induce or have them feel, but they should be able to. They have to be able to sense heat or too much cold. Otherwise, they would hurt themselves. And it's the same with us. If we lose sensation, you will get a lot of burns or wounds of your hand because you don't feel when you put it on the stove or whatever.
Right.
So it will be the same for the bots. They will have to have some kind of sensory to get the temperature and cold, hot and cold. But also shear forces, like if something is slipping across the fingers, it will have to be able to tell that. And I think they can already do that with the sensors that they have shown previously, with picking up the egg. That could probably work with also calculating the shear forces. So yeah, it doesn't perhaps have to be like a peripheral AI in itself, but you need to have the sensors there. And we have a lot of reflexes just going into the spinal cord and back out, like our muscle reflexes to adapt to load and when we're walking, and that does not have to go all the way up to the brain. But I mean, here the signaling is probably faster than it is in our nervous system, so they could put the brain wherever they want. Let's put it like that.
Yeah. That is true. So the reason I'm playing this video out is because I'm just waiting for the opportune scene where Optimus manipulates batteries from a rack. And these are circular objects. So the ability to not only see, and this is it, not the ability to not only recognize a shape, but also to be able to modify the grip in order to hold a circular object. I would imagine, but that's being done by feedback to the actuators to kind of recognize and understand the amount of pressure each individual finger needs to apply at a particular point on the circumference of the object.
Yeah, it's interesting. I wonder if it will be able to pick up a different can that weighs twice the amount, but it's the same shape, if it would drop it all the time until it's been trained on that. It's beyond my expertise, because this tripod grip will slip on these metallic batteries if it's too heavy. Right. So, and I don't think these hands have the sensor input on all of them. But maybe it's not that tricky. I'm not the engineer. It might be that, as you say, the servos or the actuators can kind of feel that when it's moving the hand, it doesn't follow along. It will directly adapt the grip. But here it's using a tripod grip, which is nice, but it's not really using the 5th and 4th digits. And so do you need them there? Probably not. But then perhaps it would be hard for it to grip it like a bottle like this.
Right.
And this one I don't think had the splaying of the fingers. It's just the pure flexion.
Adduction, right?
Yeah, the abduction and adduction, or splaying or spreading of the fingers, if you want.
Yeah.
So,
but also, it wouldn't need the pinky.
No, it can do.
Do humanoid bots need to have pinkies?
So
or is
I
that
think
vestigial?
Yeah, I mean, we have 5 fingers, and we have designed everything around us with 5 fingers in mind. So we are fine with just having 3 fingers and a thumb. So we don't really need, if we lose an index or a little finger, it's quite easy to adapt to that, and you will have be able to fully function in most.
Yeah, like even to carry an object like this tray, like this crate, you can do it very well without the little finger on both hands.
Yeah, exactly. So I wonder if they just wanted to kind of really mimic the hand to not get into problems further on if they find out, oh, we maybe needed a 5th finger because or the little finger, or if it's just to make it look really human, because we've seen really impressive 3-finger hands, or the of the Boston Dynamic, for instance. But it adds stability to the grip, and I think I've shown that before as well. If you have a heavy object, if you remove the little finger, it's a lot more force needed to be performed by these fingers to keep it stable. Here, it adds a lot. So it's a lot easier actually to lose the index finger. The little finger is a lot more important in this type of situation where you want to keep the lever arm or keep it steady. If I remove my index finger, it's not a problem. I don't have to exert any more force. So if I would have to lose a finger, if I get to choose, someone says, "Oh, Gustav, pick a finger, we'll cut it off." I'd say take the index finger, because the little finger is a lot more important than people realize for having a stable, strong grip. Whereas the index finger, you will learn to use the middle finger to do everything your index finger did in a few weeks. It takes some time to perhaps write as well, but we're really fast at learning how to use the long finger instead of the index. So we actually don't recommend replanting the index finger. If you lose it in an accident, just put it away, because if you just suture the skin, you're up and about in a few days or a few weeks perhaps. Whereas if you put it back, you have to rehabilitate the finger, the tendons need to move and the joints needs to move. You'll have a cold finger and no sensation the first 6 months or a few weeks, and the end result is not as having the original finger. So when we put it back on those who really want it back, before they have started using it in everyday life, they have already adapted to use the long finger, and that hinders them in their rehabilitation. So their index finger is just in the way. So they could probably get away with 3 fingers, but don't remove the little finger. Remove the index finger instead on the bot.
That is fascinating. Yeah, I'm sure not many have thought about that, which is why we have the good doctor in the house today. And
take your fingers away
when we talk about humanoid bots. Yeah, and it just goes to reinforce the belief that Tesla and other humanoid bot companies really need to take an interdisciplinary approach when they're developing their humanoid bots, especially the hand. And as Elon has said it in the past, the hand could be as much as 80% of solving the problem of humanoid bots.
Yeah, I think so. We already have bots that are good at certain tasks, but if you want it to be a generalized solution, you need to have the human hand or as close to it as possible. And I mean, I'm very, don't call it narrow-minded in the way that I focus on how our hands are designed and function, whereas there are probably a lot of good engineering choices that can recreate the hand, but does not have to have the tendons move all the way up to the forearm and so on. So that's, as you say,
are there any examples from nature, from the animal kingdom to
not sure. I mean, there are no hands at the same level, and since the basic setup of our extremities have been around for a long time, I mean, even if you go back to lizards, they have a similar setup of their extremities. The shape of the bones and everything is a bit different, but it's very similar. So it's been kept for a long time. And I mean,
so it's evolutionary valid,
shorter
some
ones,
form of that,
yeah. But there are like similar bones and tendons and vessels, so you would have to go into a totally different path, like an octopus or some kind of sea slug, I guess. And the octopus is really good at using its tentacles, It can open the cap of a bottle and squeeze its way in, and so there are other solutions out there. But looking at the mammals or reptiles or others, it's quite a similar design. It's just that it's evolved to fit their niche in nature.
So here's a bit of a curveball. If we're gonna design and develop a humanoid bot hand, do we need to limit its functionality to that of the human hand? Or, as in some cases, why not make it perhaps as strong as a hand of an orangutan or an ape with that sort of functionality?
Yeah, I think they probably could and should, since it won't be as durable as our hands, probably, at least not in the beginning. But if they can kind of over design it to make it stronger, perhaps it will last longer. And I don't see why it wouldn't be possible. I mean, today it's not really possible to make a good human hand, so they have to solve that, of course. But in the long run, why not make it able to crush metal bars or pull apart concrete with their bare hands? I mean, it would look cool, at least. But then I guess the size of the hand and the size of the joints and actuators will probably bring with it some limitations. But who knows, with development of new materials, it could be stronger and stronger for each generation.
Yeah, I mean, we've seen the strength of the actuators, and this is the actuator in the leg that Tesla demonstrated really early on. So, I mean, it's not as if you wouldn't need the hand to lift a piano as this actuator is doing, but you could make it really super strong.
Yeah, and there are probably uses for that. And I mean, I like Tesla's point of view that it shouldn't be that fast. They will probably never be able to compete in the robotic Olympics if it's not going to be able to. Yeah. If it were going to make for that, they would be able to win probably. But I mean, they choose not to make it be able to outrun a human for a certain reason. And in the same way, I don't expect them to make the bot able to crush your head with its hands, because they don't want to go that route. Someone probably will militarize this in the future, of course.
Yeah.
But I mean,
Terminator bots.
Yeah, seemed like a good idea at the time.
Famous last words.
Yeah.
All right, so let's take a look at the latest images that we have of Optimus. This is Optimus 2.5, Gen 2.5, as Elon clarified. These are images from the 2025 compensation plan that the board filed with the SEC. These hands are slender.
Yeah. And we mentioned previously that perhaps they are just mannequin hands with a nice glove, but it's not exactly the same as in the film clip where it had the golden-ish hands that were really stiff. So perhaps this is the intermediate going towards the hand from 2.5 to number 3. I mean, the ball catching hand had a similar size to this, so it might be that they have a solution to keeping them slender. I mean, the hand, since they're moving all the muscles or the actuators out of the hand into the forearm, the hand can be very slim, but then I would expect the forearm to be a bit bigger as well.
So this arm on the left that's catching the ball is similar, you're saying, to...
Yeah, and as far as I can remember, this was supposed to be the Gen-2 or the air guitar hand design, at least based on that, and it's not the same as on the other hand, which is the Gen-1, I guess. So it's, it was supposed to be this tendon-based design, at least that's the way I remember it. But it looked really slender, and they had nice control of it, quick responsive reactions to catching the ball. But yeah, so the last picture we saw, in a way, I'm wondering, why are they showing it? Is it just to put a nice cover on the documents? If they have kind of made a big redesign and everything.
It's not in their DNA to signpost something that they aren't secretly working on.
Yeah. Yeah, exactly, because he said that it will be a big redesign of most parts, and maybe the
I think you used
aesthetics
the
will
word
be the same.
sublime, if I'm not
Yeah,
mistaken.
exactly.
And
Yeah.
that really stood out to me.
Mm.
The choice of that word just indicates how mind-blowing he thinks Gen-3 will be.
Yeah. And in this last talk with the All In podcast, he also kind of indicated that they haven't really managed to finalize the design of the hand yet. They are not satisfied with what they're having, and there are good alternatives out there, or some promising, and they've looked at all of these, I'm pretty sure, but they're still working on the final design. So it would be really interesting to know what they find is the most complicated parts, if it's the control or if it's the whatever it is it the structural stability, or do the actuators burn out, or
we have to find a way to get you inside that team.
Yeah. I'll spill all the beans when I no, I'm really looking forward to seeing what their final design will be, or at least at the time it will of course evolve probably from generation to generation of bots. Yeah. But also hearing what were their biggest problems with designing the human hand. Why is it taking so much time, and why are they redoing it? What from their point of view?
So maybe there's a hint, and this is the last thing I wanted to touch upon, and this is Elon posting, and this post was on the 10th of September. There's this gentleman named Luis Batalha who posted this animation saying this is the chaos produced by a triple pendulum with just 3 degrees of freedom. Your hand has 27, 4 per finger, 5 plus 5 for the thumb, plus 6 for the wrist. And this is just 3. To which Elon then said, designing dexterous hands for robots is a very hard problem. Then figuring out how to manufacture them at scale is 100 times harder. So is it really that hard? Is the movement as complex for this, or should we do a bit of fact checking here, Gustav?
Yeah. I mean, I'm not a software engineer. I let Grok and the chat write all my scripts and apps, but I think it's a bit of a false equivalent. I mean, there will be design elements in, like the finger, for instance, that sure you will have to control having it flex, but you don't have to control the individual joints. I mean, this joint follows along due to the design of this robotic finger. So I don't have to control this joint. It just follows along thanks to the mechanical design of this finger. And I would and it stops. It doesn't spin the other way around. So you don't have to program it to stop. It will just be the design of it. So sure, I'm not going to take away from the problems of developing the software for these bots. But Elon himself kind of said that it's the hardware, it's not the software in making the dexterous hand, as a response to that question in this interview. And it always comes to the manufacturing. I mean, here, sure, it will be tricky to mass manufacture them, but I think finding the best design is probably a really big problem. And if you solve that, then manufacturing them will feel quite easy compared to the speaking.
Yeah, because if you scale up the wrong design, that's far from any situation you want to be in. It's suboptimal. By a long
and I mean, it's not like people haven't been working with this. People have been building robotic hands and prosthetics for decades, and at least the last 20 years they have really been high end. But as Scott often mentions, you see some fancy design on a video clip, and then it's gone and never seen again. So there are a lot of really clever people who've been working with this problem for many years, but there's still not a good design out there. So
it just goes to show how great an artist evolution is.
Yeah. and how extremely difficult it is to be a hand surgeon. I mean, it's probably it's almost like Starship. It's rocket surgery.
It's rocket surgery, if that's what it is.
No, but yeah, it is. I of course I'm biased. I work with hands, and I like the anatomy part of it, and I like the aesthetics and everything. But I really think that the human hand, it has really. I have a hard time improving on it. I mean, aside from the things you mentioned with increased strength and the stability, and maybe a little bit more. No, not even speed. I mean, it is hard to find a match or something better in nature when it comes to manipulating things.
Let's not forget Bruce Lee and martial artists, and people have extremely high reflexes when they train to have them. So it's not a lack of capability. It's perhaps more about the ability as a lack of training.
Yeah, I mean, artists of painters and making statues or working stone or musical instruments. I mean, the way we can express ourselves with the hand is part and none. It's hard to compete with the eyes when it comes to importance as like taking in your surroundings.
Right.
But after the eye and vision, I would say that the hand is probably our most important.
I think Elon's working on a solution for that as well, right?
Oh yeah. It will be. Well, I mean, parts of it when it comes to Neuralink, and I hate kind of call it doubting Elon, because history tells us that it's doomed to
don't bet against Elon.
No, don't bet against Elon. But the same when it comes to like, will they really manage? I mean, there's a lot of clever people who have been working with brain neural interfaces.
Well, it doesn't break the laws of physics.
Yeah, exactly. No.
Yeah, and people have been working on BCI, brain computer interfaces, and earlier versions of the Neuralink type of devices for decades. It's not a new idea.
No.
It's just that Elon comes in, and within a few years, what is it? Is it a combination of money and bringing the right people to the team?
I think, and he's getting the team focused in a way that others can't. Of course, money will help, but I mean, when he started SpaceX and Tesla, it was not
the intersection of the right technologies and the right science maturing at the right time. Is that also playing into it?
It could be, and that he is really good at seeing this and taking it back to first principle thinking. I think is a skill that a lot of people are missing. I mean, especially there are a lot of unnecessary activities in everyday life and in academia, and you kind of get stuck in your ways, and you forget, okay, what is the minimum thing we need to consider when looking at this problem?
Right.
So I think that is one of his strengths. Finding the right people, hiring the right people, paying them. Of course, the money is not an issue for him anymore.
But a lot of people who work for him also do it just because of the thrill of being on the edge, on the bleeding edge of discovery and innovation and invention.
Yeah, and I think he allows, he creates an environment where people can excel and do things. I mean, it's the same engineer who would, if you'd gone to another company, I don't see them managing to do what Tesla has done. But it just gives me high hopes. I'm glad that they went for the humanoid bot production and development.
Well, we're both Tesla bulls, so
it's not a secret. I think
it's not a secret, but we like to keep our audience grounded here on Over the Horizon.
Yeah,
because it's important to fact check. It's important to get the right perspective, the right insights, which is why we love bringing interdisciplinary teams together to look at it from as many different perspectives as possible, because these are intersections that you have multiple arcs of innovation converging on. So it's important to get the right perspective and to stay grounded.
Yeah, I think so. And that might have been one of the problems in the early stages of the Optimus project, that they they did not perhaps not think outside their engineering box. I don't know, or they did, but it's just that they tried to kind of downsize it. Okay, how can we?
Maybe they just underestimated the problem and overestimated their ability to solve it.
Yeah, and I mean, Elon they have changed. Just look at their cars. I mean, they put in radar and everything in the beginning. Then they remove it when they realize we don't need this, or this is a problem, and they had to rethink the whole FSD, going to all neural nets instead of trying to just code their way through the problem. So he's set in his point of view and ideas, but they are not afraid of changing their minds or changing the approach. So that is probably also a good skill set. I mean, within a lot of industry, it's suicide to say, okay, we're gonna scrap this and start over. Then you're out of a job and we'll find someone.
And medicine.
And science and medicine, yeah.
Thank you so much, Gustav. Always a pleasure talking to you. And to my audience out there, if you really want to understand more about why the human hand is so complex, you need to listen to Gustav. And where do you find him? On Over the Horizon. Please like and subscribe and stay up to date with our chats. Always a pleasure having you, Gustav. Till next time.
See you on the next one.